computer proficiency for those individual who will becomes the end user of the application. There might be the limitations on the training associated with project management software usage. There might be also a problem for the need of software process improvement. And lastly is the stage of the adoption of the application. So for me to justify the third objective of the study, this has been crafted based on the findings and the outcome of the study. So this is the proposed framework in the analysis of the functionality and the security concept as well. So the usual phases of the SDLC or the systems development lifecycle signifies the yellow entities that includes planning, defining of the requirements and specification, development, testing, operations, and maintenance. So it's the usual activities are shown in the white entities, just like the governance during the planning stage, defining of the requirements and specification. The students are in need to create system requirements and also to develop functional specifications. For the development stage, they have to code the unit to test, perform integration test, prepare initial documentation, development acceptance plan, fix test defects. And for the testing stage, it includes the verifying test preparation, test staging, performing integration test, and test production. And for the operation and maintenance, it includes the integration test and environment. So what has been added in this framework is that governance should not only be improved during the planning phase, but it should be doubled during or in between the development and testing phase. It's because the tracking of issues and concerns against the software application has been noted. So what has been added also and the highlights of this framework are shown in the blue entities, such as there must be an additional or I mean must be reported into the one that guides the students tracking the report cases. And also in between the development and testing phase, there must be a develop test strategy. It's because it has been observed that the ISO 9126 is just a metric to evaluate the entirety of the system, and it does not work out truly for the core function of the system. So what has been added here is that there must be an additional expert to review the metrics as to whether it is still uh, useful enough to study the composition of the system. So for the results and discussion, the history of the records for the 3 consecutive years of the academic year, years 2016 to 2019, has been revisited for the purpose of identifying the possible strengths and weaknesses of the software projects found in the summary of evaluation of the experts, students, and target audiences. It has found out that the functionality became the ground among the software characteristics, and the usability became the least sub-characteristics or subcomponents of the functionality. So for the conclusion, so number one shows the degree of influence of the mobile applications against the metrics being used. Number two, the ease of operation having the average mean of 4.53 under the software characteristics of functionality receives the least evaluation from the said metrics. The framework shown in Figure 3 has been developed for the trade-off analysis and the enhancement of weak subcharacteristics of ISO 9126 found in the study. For the recommendation, the study focusing on the enhancement of functionality of the system must be looked upon by the developers in order to improve and give satisfaction to the users. The tail of the study also implies that developers should also have to review and or add other isometrics aside from ISO 9126 that will have the focus in the evaluation of the functionality of the software product. Also, it is being recommended to intensify the orientation for the usability of the software product. So these are some of the references being utilized. And with that, thank you so much.
Thank you for your presentation. Now we have a room for questions. You have 3 minutes. Any questions?
Hi, it was a nice presentation. So my question to the presenter is, since they have used, she mentioned like she has used various random sampling techniques for the study. Could you please mention what techniques you used randomly?
Um, during my during for the methodology of random sampling techniques, out of I just choose it among those individual who has submitted the manuscript per year. So it's not in the proper sequence, and it's not in the proper order. I just pick up by its word random sampling techniques. I had utilized and I had picked up several examples of manuscript from our library.
Okay, yeah. So since you mentioned you have used various random sampling techniques, that's why I got confused. Like, what were those techniques? Now I think I'm clear. Thank you.
Thank you so much, sir.
Okay. Um, any other questions from the audience? Okay. We will move to our next presenter.
Thanks so much.
Thank you. The next presenter is Inkili Iri, presenting examining the service load average when trying to attack the firewall. The floor is yours. You have 12 minutes to present.
Hello, hello everyone. Thank you for this opportunity for giving me the opportunity to present this paper. I wish to everyone a good health. Just excuse me for one moment to share my screen. Okay, do you see my screen now?
Yes, it is visible. Yes.
Okay, so we are going to present an average when we are living in a digital world, and we are living with digital more than ever this last year due to COVID-19 and the problems that it caused to the world. But having this negative impact is also a good impact. Communications between people are more genuine, more active than before. So this type of conference gives the opportunity to all of us to collaborate even more with each other and exchange ideas, presentations, and works. And science does not stop. This is the idea. So regarding the agenda, I will give some security information in general. We will give the problem, the anti-DDoS mechanism, and the focus of this studying on fail to ban package, that is a standard package within the Linux subsystem. But the idea is to test the performance of computing systems regarding these DDoS attacks. So, as I said at the beginning, we are living in the digital world, and we are at the same time, I'm a user outside of work. That's on working hours, I'm a provider. Let's say we provide server and services to all people around the world. And we have like that old fiction film that I said, there are three types of clients, the good, the bad, and the ugly. And also we have three types of servers, the weak, the vulnerable, and the solid one. But these are all dependable from technology and on the user experience and the user proficiency to configure and harden the systems. So the servers are offering a rich type of services, but these services from time to time are target for attacks, for getting juicy information and getting unauthorized access. So I said that we are in this kind of COVID-19. It's still unresolved, but with the hope of the science, everything will be okay by the end of this year, on the next year. Uh, and opening to technology, being connected, IoT, all these kind of technologies that we know uh, are based on open source software. Being open source software, most of systems have some vulnerability in it, and that can be used by some other attackers. So businesses are in risk, and these IoT devices can be used by anyone in the world. Firewalls are our oldest friends, one of the oldest device on the business for protecting networks and services. There are plenty of other technologies that have have been produced behind the firewalls, but we are speaking for those today. So we have some type of firewalls, packet filtering, secret level gateway, stateful firewall, application level gateway, and multi-layer inspection firewall. Based on budgets, we are on commercial or paid firewall and free or open source firewall. I said that more and more people are going to the and using free software, but free software isn't always free. This is the idea, free in the sense that they might have security holes in it, and they can pose a very big security risk to companies or protecting data, even in universities. So the performance, the problem that we have is to measure the performance, the issues on systems and services, and the availability. One of the most biggest problems today regarding the data, we have also to have availability of the systems. So people not going out have to have also secure services, but more and more availability of services. And this availability, it is one of the top priorities of all businesses and all kind of services that people want to access. So we have this anti-DDoS. Attackers are becoming more and more sophisticated. They are using distributed systems. They are using IoT devices that are vulnerable. That are these devices are using, let's say, open code that is public to the internet, but they have some bugs. So we have some local anti-DDoS mechanism, but mostly anti-DDoS mechanisms reside in the cloud, and this for distributing load to the system. But you know, cloud protects from outside world. From the insider attacks, we know that most of the problems come on security come from insider threats, and this is the case of an ugly user. Fail2ban is an intrusion prevention software that protects the computer from some brute force attacks on protected services. The main idea is, let's say, secure shell, and it's a tool that is combining IP with fail logins. So it does a cross reference between these two. But let us see with the viewpoint of a user not having too much experience and not being too much proficient for fine tuning the application. So we have created this attack with 4 clients that are used from a server that is controlling these clients, and they are launching an attack to another server. So let's simulate a simple DDoS attack. And we will measure the performance, the response, and the load to the system. And we know that the biggest problem with DDoS attacks is the time that the system is under attack. Oh, excuse me. Problem with I can't put my document here, so okay. So these are the graphics that I have generated. I had to put it on the document, and we see that in a minute, the load average. We have this kind of system that the load average. Wait a moment. Wait a moment. Just a moment, because it's. Okay, because I was sure that I put that. Okay, and the results after one, we have configured the fail to ban, drop request after total 10 requests, 30, 60, 90 requests, and no dropping. So this is the case of the system, the server that is accepting this ICICT automated connections, and we see that the load
Excuse me,
average.
excuse me, we cannot see your results or anything. The slide is blank.
Just one moment. Just one moment. Just one moment. Okay.
Yes, we can see now.
So we see that the load 1,000 to the normal usage of the server, and having this attack on 5 minutes, the load of the systems goes even much further. But having this load, the system itself cannot process any more data or services that are available to users. So it can, the whole, let's say, concentration of the systems goes on giving the responses. And this is a case of a classical attack. And after 15 minutes, this is the output of measurements of performance data taken from the system, and we see that the load is even greater. So as a conclusion, the idea is that all systems and all of us are vulnerable at some point. So distribution of this load relaxes the systems and gives the opportunity to have the other services available. Somehow or some way we must have an access to a system for doing maintenance or doing some other configuration. And this is the mechanism that attackers are using, and they are trying to getting in or causing some distributed attacks and causing non-availability of the systems. As a conclusion, I would suggest that overcoming the bad configuration with intelligence, artificial intelligence, or using some central of malware services and cloud services would be the solution for everything. I would like to thank you and wishing to everyone a good health, and together we will come over. So any question?
Thank you for your presentation. Now it's time for questions. You have 3 minutes for questions.
I have a few questions. Thanks, Anthony. The first question is that my understanding is that this fail-to-ban system can be installed on a server system. Now, if that is true, then I would like to know how can your fail-to-ban system differentiate the requests from legitimate IPs? Because there can be if we have several IoT devices on the network and all of them are the legitimate, they will definitely push too much of data. In that case, how will your fail-to-ban system identify those basically those packets?
Yes, that I was saying. Thank you for the question. That the idea having an intelligent system, so that has some, let's say, pattern matching or some history in it. So building an intelligence inside the system, or some intelligent system that gives feeds to the protection mechanism of the system itself, or some other packages that are doing, let's say, intrusion prevention mechanism. So let's say we have a database, or the system itself has a database, and he is storing a history on IPs that were connected to the system. And at some point, with the intelligence, when it sees some other IPs that are not seen before, he might have a greater sense of protection, and with known IPs it might be some a little bit lower, but that has to be done with some fine tuning with artificial intelligence on some packages that more and more are used in technology now.
Yeah, thank you for the clarification. That's what I want to understand. What is that intelligence? Because this is not clear, like what intelligence you will be building in your system so that you can differentiate requests which are like you are getting for the first time, whether it's a kind of attack or it is a legitimate. So what's that intelligence?
uh, uh,
Or is
so
it simply a database you want to maintain and you will cross check every time database?
I don't the idea to have a trained system, so, or a neurologic network that uses some data that are exchanged between each other, and then served to the system based on requests, so matching, uh, let's say, a database of clarification of personality, let's say, for IPs. So like now we have a gray list of IPs or blacklist of IPs on email systems or on network traffic all over the world. This would be like a microservice for IPs that are connecting to our, let's say, internal service.
Okay, thank you. I think now it's clear.
Thank you very much. Bye.
Okay, thank you. Any more questions from the audience? Okay, so we're going to move to the next presenter, which is Naohiro Ishii, presenting iterative generation of Chow parameters using nearest neighbor relations in threshold network. The floor is yours. You have 12 minutes to present.
Basil, I think he is not here.
He is not here.
I
Yeah,
don't think
I
that.
do see Ishii here in this room, but he's not answering. I don't know.
Because his audio and video both are off.
Yeah.
So I think for the time being, we can move on to the next presentation, and then later on, if he joins again, we can come back to her.
Okay, to the next presenter. The next presenter is Nakisa Shams, presenting a channel allocation algorithm for cognitive radio users based on channel state predictors. The floor is yours, and you have 12 minutes to present.
Hello, everyone.
Hello?
Can you hear me?
Yes, we can. Yeah.
Okay, perfect.
And it is visible, the presentation.
Yes. Can you see my screen? Is it okay?
Yes, yes, yes.
Okay, perfect. Thank you so much to attend my presentations. I'm a PhD. My name is Nakisa Shams. I'm a PhD student at École Technologie Supérieure in Montreal, Canada. Today, my presentation is about a channel allocation algorithm for cognitive radio users based on the channel state predictors. First of all, we have an introduction, then talking about the centralized channel allocation algorithm using channel state predictions and cognitive radio performance with channel state prediction. Then we are talking about the performance evaluation, and at the end, we have conclusion. As you know, by purposing of the technology, all the electronic devices would like to connect to the internet and using the bandwidth, and we encounter to the spectrum shortage, and researchers would like to find their solution to share the spectrum and channel to the all users. And then we have a cognitive radio networks. As you know, cognitive radio networks can efficiently manage the radio spectrum by utilizing the spectrum hole for secondary users in the licensed frequency band. Actually, secondary users are users don't pay for the spectrum, and licensed users, for example, like military and government, pay for spectrum and channel, and secondary users try to use the licensed channel, and when the licensed users, primary users, don't use the channel at the same time. And the main task of the cognitive users actually is sensing, reasoning, learning, adapting to the spectrum environment. Actually, I mean, the cognitive users needs to at first sense the whole channel spectrum, and then learn how to find the ideal channel, the channels that are not using by primary users, and then adapt itself with the spectrum environment. One of these cycle is learning. Learning is the process of gathering knowledge after applying decisions, observing their effects, and then adding new information to awareness. Centralized channel allocation algorithm using channel state predictions. How it works: secondary user in a cognitive radius systems try to find and use the ideal channel to reduce its interference with the primary users. Primary users is licensed users actually. So there is a need to employ channel state predictions. Channel state prediction means we need software, we need the devices to predict the channel for the future, to identify and choose the best communication channel. The knowledge requirement of primary users can be eliminated by using the channel state predictions. Channel state prediction can be performed with two different networks: time delay neural networks and recurrent neural networks. The main difference between time delay neural network and RNN recurrent neural network is that the recurrent neural network has a feedback, and it helps to provide better results, because it can have a feedback and know about the results, and then apply the error to the network and train itself again. Here we see the centralized channel allocation algorithm for secondary users. Consider we have n secondary users in a network and just only one primary users. Actually, to simplify the network, we consider one primary users and several secondary users. And we have around, in the simulations, we have more than 20,000 time slot. Actually, time slot is that it's a channel, and every channel divided to time slot, different time slot. And secondary users try to sense the channel each time slot and try to find the ideal channel and try to know about the distribution process of the primary users. As I mentioned, there are n secondary users on the network. Each secondary users, each channel state prediction. Channel state prediction are based on a neural network, and in this presentation we use two different neural network, TDNN and RNN. And each secondary user using this own channel state predictions. The distribution of traffic on the channel of primary user is same for all secondary user. Actually, this assumption is for simplification, because in the real world we don't have a static distribution traffic for channel, and it would be very hard to simulate and to simulate the real distribution of the traffic for primary users. So for simplification, we consider the all secondary users can see the primary user as a static, and then in each time slot the channel is free with a probability of PM, and occupied with a probability of 1 minus PM. Each secondary user try to learn traffic model of the primary user by using its channel state prediction. By considering several secondary users in the system, we have two concepts: interference between the primary users and secondary users, and also interference between secondary users. Interference between primary user and secondary user, this interference occurs when secondary users select the channel occupied by primary user and transmit data on the channel. Secondary user actually occurs when more than one secondary user select the same channel for data transmission. So this centralized channel algorithm allocation help us to provide minimum switching between the channel, because secondary users try to find the best channel, and when the primary users use the channel for transmit the data, so secondary user cannot use it, then we have to have a solution how to provide the fairness between all secondary users during a specific time slot, and having the minimum switching between the channel. When secondary user cannot use the specific channel, they have to switch to another channel, another time slot, to find the best one for transmitting data. Cognitive radio performance with using channel state prediction. We considered several things. First of all, considerable energy is consumed by sensing the spectrum. So secondary user can save energy detection by preventing the occupied channel from being detected during the sensing. Spectrum usage can be improved by achieving a low probability of false prediction in an idle channel. In order to have a benefit channel state predictions, they are expressed using a presentation of improvement in spectrum usage of SUI, and presentation of reduction in energy sensing, SER, and we calculated SUI and SPR like that. Yes, you can see the formulation of that one, and also about SER, overall sensing energy for all time slots, and total sensing energy for those channels whose states are idle during the respective time slot can be expressed like that. And then by using this formulation, we have some figures and to show how the channel state prediction helps to save the energy and improve the sensing process. performance evaluation. Evaluation actually divided into two groups: performance evaluation of the centralized channel allocation algorithm, and cognitive radio performance in spectrum usage improvement and in sensing energy reduction. First of all, we have looked at performance evaluation of the centralized channel allocation algorithm. Here, this figure shows the comparing number of the channel switching by 5 secondary user under a static traffic condition in time slot equal to 20,000. As you see in the figure, we have 4 different groups. The 2 of them are related to the TDNN, time delay neural network. First of all, is related to the first hidden layer. Second one is related to the second hidden layer. That's related to the layers of the neural network. And then we have a recurrent neural network with 1 hidden layer and second hidden layer. As you see, the recurrent neural network provide the minimum switching, channel switching compared to the TDNN recurrent neural network, because of having feedback and connecting the output to the input of the network. It complicate. Actually, the structure is more complex than the TDNN, but it provides the better result in number of switching by using the recurrent neural network. Number of switching between the channel for secondary users is less than the TDNN, and after that, this figure shows the fairness between the TDNN first hidden layer, TDNN second hidden layer, RNN first hidden layer, and second hidden layer. As you see, when we consider 5 secondary users in the network, then there is a fairness between all secondary users by using each neural networks. And then cognitive radio performance in spectrum usage improvement and in sensing energy reduction. This figure shows that performance of the 4 channel state predictions as a percentage of the improvement in spectrum usage by increasing the number of channel. Improvement in spectrum utilization, it will be increased. This table compared the spectrum usage improvement based on the TDN when using the TDN and 1 hidden layer, TDN and second hidden layer, RNN 1 first hidden layer, and RNN second 2 hidden layer. And by using the RNN first hidden layer and second hidden layer, the percentage of improvement in spectrum usage is more than 82% and 89% respectively. This table shows the proportion of energy saving, energy reduction as a percentage for different traffic intensities. The highest percentage of energy sensing energy reduction is 73%, and lowest percentage of sensing energy reduction is 50%. So, as a conclusion, we propose that centralized allocation algorithm based on the channel state predictor is presented. The channel allocation is evaluated by number of the switching on the network and fairness between secondary user. The channel switching probability in the multiple secondary users is less than 2%, less than 400 out of 2000 time slot, and the channel status prediction saves the energy saving and improve the spectrum usage. Yes, thank you so much for your attentions.
Thank you for your presentation. And we have 3 minutes for any questions. Any questions from the audience?
Thanks, Nargis. I have a couple of questions. One of the questions is that since we know this spectrum consists of several channels and the usage of channel depends on the availability of the primary and secondary users. Now while knowing that, I also know that you have used the simulated results. So I'm a little bit curious about which models you use to generate the traffic, like basically the usage, like the usage or the presence of the primary and the secondary users within the spectrum.
Sorry, I can't understand your questions. Can you repeat it again? Sorry.
Yeah, sure. So in real world, like how the primary and secondary users behaves, it depends upon the current instance. Maybe like right now, I have 1,000 users for few channels for and for 500 users as a secondary. Now, since you are using the simulations to generate the traffic, I want to know like what model you use to generate this traffic, like how the requests for primary or the secondary users are coming for. Is it clear now?
Actually, I think actually, do you want to know about the distribution traffic of the primary user and secondary users?
Yes. What models you used for distributing the data?
Okay. Actually, for this paper for simulation, we consider the Poisson distribution for primary users, and primary users don't have the specific distribution, and usually using and communications students are using the communications distribution like Poisson process. And in this paper, I'm using Poisson distribution for primary users, and secondary users doesn't have information about the primary users. First of all, they need to sense the spectrum and channel to find distribution of the primary users, and actually by sensing they can find, for example, the distribution is Rayleigh distribution or Poisson distribution, and then they can learn this distribution and train itself, the second user train itself, and after that for future they can learn in which slots are idle and which slots are occupied with primary users.
Okay, yeah, that makes sense. Thanks. And another question I have, since you are using this deep neural networks for these results, uh, do you know like what's the minimum amount of data we require for this kind of analysis?
Yes, as much as we have more data, it helps to have actually accurate results. But
Yeah,
in order
that's
to know,
yeah,
yeah,
that's well, that's very fair. Like the more the better. But I want to know what is the minimum? What's the
yes,
minimum data you require?
as much as we can have in a neural network we have MSE, mean square root, error of the training for LN for neural network, and when we try, for example, when we consider 10 time slots, when divide the channel in 10 time slots for the spectrum or for channel, then we train the neural networks with this data, and after that we can see the mean square root of the neural network. The minimum square root should be less than, for example, 5%. Okay, and then with this criteria, we can understand that this data is enough for neural network to be trained or no, and then we need to increase the input data of the neural networks as a channel state prediction to find the best results for predictions. As much as we can find the data to train the neural network, we can say that it's the minimum data to train to predict the next time as well.
Okay. Oh, thanks.
Welcome.
Well, thank you. Okay, now we will move to the next presenter, Ivan Al-Aslaw, presenting music genre classification, a comparative study between deep learning and traditional machine Machine learning approaches. The floor is yours. You have 12 minutes to present.
Hello, can you all hear me?
Yes, we can.
Yeah. I'm just sharing my screen. Can you all see my screen?
Yeah, it's usable. Yeah.
Okay. Hi, good day, everybody. My name is Devin Lau. I'm a computer science honors graduate from the University of the Witwatersrand in Johannesburg, South Africa. My research topic is a comparative study between using a deep learning convolutional neural network against 5 traditional off-the-shelf classifiers in the field of automatic music genre classification. Just for some context, I'm sure most of us love listening to music. It has played an important role in society as it is a means of entertainment, bringing people together and building communities of people who share similar music tastes. Music streaming services such as Spotify, Apple Music, and SoundCloud are increasingly growing and looking for faster, more efficient machine learning models to be used for music information retrieval, classification, and recommendation. Music genre classification is just one way of grouping similar songs for making recommendations to its listeners. For the problem statement and research overview, automatic music genre classification is a supervised machine learning problem. Classifying music by their genres has been an ongoing problem in the field of automatic music classification. This is due to their abstract and subject nature, as overlapping genres for a given song are becoming more prevalent with the evolution of music. The use of deep learning models has risen in popularity, and as such, our research provided a comparative study on music genre classification using deep learning convolutional neural networks against 5 traditional off-the-shelf classifiers. Feature selection includes both spectrogram images and content-based features. I will further discuss these features later on in my presentation. Some previous literature. Here's a table showing some previous notable works on music genre classification using various datasets and their best classification accuracy for a given model. We see that the convolutional neural networks on the Free Music Archive and the Nava Music datasets show some very good classification results at 88% and 75%. We have chosen the famous GTZAN dataset as it is one of the most popular publicly available datasets for music genre classification. This dataset contains 1,000 sound excerpts that have been, excuse me, this dataset contains 1,000 excerpts that have been uniformly distributed into 10 music genres, namely classical, hip hop, country, rock, metal, blues, pop, jazz, reggae, and disco. Each audio sample is 30 seconds long. We further process this we further process this dataset by splitting it into 10,000 audio samples, where each sample is 3 seconds long. This is to produce more training data for our models. As we know, the more data we have, generally, the better the machine learning models will perform. For the sorry, for the method, there are 2 types of features that we use in our training. The spectrograms, which are 2-dimensional graphical representations of an audio signal. They are essentially images which can be fed into a convolutional neural network, which in the past have proven to be very good at classifying images. And then content-based features. These are characteristic features of an audio signal that can be quantified. They're extracted from both the time domain and the frequency domain of an audio signal waveform. Some examples of these include the tempo of a song, spectral features, the zero crossing rate, and null frequency cepstral coefficients. We used a total of 3 feature sets for the training of our models. The spectrograms, the content-based features extracted from the 30-second sound excerpts, and then lastly, the content-based features extracted from the 3-second sound excerpts. The models that we use, the 5 traditional machine learning models that we chose was logistic regression, k-nearest neighbors, support vector machines, random forests, and a simple multi-layer perceptron. These were selected based on their high classification scores from previous literature. and they were only trained on the content-based feature sets. For our deep learning approach, we implemented 3 convolutional neural networks, or CNNs for short. Each of these CNNs were separately trained on the spectrogram and the content-based features. For our results, in the first table, we see the traditional classifiers trained on the 30-second feature sets. Our results found that the random forest model had the highest classification accuracy for both the validation and the test accuracy amongst the other traditional classifiers at 69.33% for validation and 74.5% for their test accuracy. In the second table, the k-nearest neighbors model had the highest accuracy for the 3-second feature sets. This is at around 92% for both the validation and the test accuracy. It's also worth noting that the least time was taken to train this model at 78 milliseconds amongst the rest of the traditional models. And then lastly, in the third table, we have the CNN trained on the 3-second feature set produced the highest accuracy at 72.4% amongst the other CNNs. Making some quick comparisons, we can see that the 30-second CNN performed significantly worse than the traditional models at a low 53.5% accuracy, seen over here. This may be due to the small amounts of input, the small input data sets, as neural networks in general require large amounts of input data for better results. This is justified by the CNN trained on the larger 3-second feature set, as it gave an accuracy of 72.4%. However, this was still a lower accuracy compared to the other traditional models as seen in Table 1. Lastly, the spectrogram CNN had similar results to the 30-second traditional classifiers, also seen in Table 1. Here are the confusion matrices for each of the highest classification models for each feature set. We have the true label of the classified sound accept on the y-axis and the predicted label of our models on the x-axis. Results are favorable, as we see many of the classifications fall into the diagonal of all 3 matrices. And in conclusion, we found that our traditional models outperformed our deep learning models. The spectrogram CNN model did not perform as well as we expected. This may be because our CNN model was not properly optimized during the implementation, and that the traditional models were implemented from an optimized Python library. We also found that by further splitting our data sets, we were able to reduce more training data, which resulted in higher classification accuracies across the board. Further research into more complex deep learning architecture and better feature selection may improve the classification results. This is the end of my presentation. I would like to thank ICICT for this opportunity and to everyone who listened to my presentation. Thank you.
Thank you so much for your presentation. Now we have 3 minutes. Sorry.
Thanks, Diwan. I have one question. Were there any features, or basically, were there any genres which can be classified easily as compared to other genres?
General, sorry, I couldn't understand what you said there.
In your data set or in your analysis, there were, I think, 7 or 8 genres. So I'm asking, were there any genres, like any out of those 7 or 8 genres, were there any 1 or 2 genres which can be easily classified or picked out of the remaining ones?
Sorry, I'm struggling to understand your question.
Okay.
Oh, are you saying genres? Sorry, genres.
Yeah.
Yes. Sorry, can you just repeat the question again?
Yeah, the question is, like, out of those given genres, is there any 1 or 2 genre like which were classified easily?
Oh, I guess if we look at our confusion matrices, what I did notice from our confusion matrices that we did find that for disco and rock, those 2 genres were actually the ones that conflicted the most with each other. As for the rest, I see country And I think as for the rest of the genres, they classified pretty well with each other. We just found that disco and rock had some misclassifications between each other.
And what was the reason, like among those, like disco and rock, like why like the accuracy low? Are these?
It may be due to their very similar structure in their spectrogram images that were produced from them, and also just similar features. They had similar feature sets.
Okay, yeah, makes sense.
Okay,
Thank
thank you
you.
for your question.
Okay, thank you. Any more questions? Okay, so thank you for your presentation.
Thank you.
Okay, now we are going to move to the next presenter, Rudzani Milauzi, presenting demonstration that the use of feature selection on high-dimensional South African macroeconomic data results in improved performance. The floor is yours. You have 12 minutes to present.
Yes, can you please enable me to share the screen?
You can share the screen.
Okay, let me try again.
Yes, you can share.
Okay, I can share the screen now.
Yes.
Yeah.
I am sharing my screen. Please let me know when you can see it.
Yeah, we can see it.
Okay, perfect. So I'm going to be presenting the demonstration that the use of feature selection on high dimensional data results in performance improvement, and particularly by performance, I'm referring to the mean absolute scaled error. This is a paper by myself and my supervisor Ritesh Ajuda, but I will be presenting on our behalf today. So I'll cover 5 key parts today, just contextualizing firstly the South African unemployment problem. Then I'll give you a sense of what data we used, and then I'll talk about the feature selection techniques as well as PCA, and then I'll provide some concluding remarks about the paper. So unemployment is undeniably the biggest problem in South Africa today. Many have labeled it as a humanitarian crisis. So as it stands right now, we are at 23% unemployment, but that's also as a consequence of people being unable to search for jobs. So the real unemployment rate is much higher than that. So officially in December, in May 2020, we're sitting at 30.1%. And for the youth sort of population, which are those people that are aged between 15 and 35, those people's youth unemployment rate is really around 60%. So it's a scary reality that we find ourselves in. And when you want to resolve unemployment at scale, what you would do is that you would rely on policy. And there's been multiple policies that have been tried and looked at in order to resolve this particular challenge. However, policy is reliant on good, sort of sets of features to actually consider. And in our case, we're looking at a lot of features. So there are about 147 possible key critical features that one could model the South African sort of economy on. And we looked at all 147. Obviously, those are very overwhelming and can be disabling to the policymaker to make a decision on what is important or not. And hence, we looked at feature selection as possibly a solution that can help us to overcome this challenge. So when you think about feature selection, there are essentially three types of feature selection techniques: the filter, the wrapper, and the embedded methods. Those are the ones that on this diagram, they're labeled as variable enumeration. But there's also pre-processing opportunities that you can use dimension reducing techniques. These are often referred to as feature selection techniques as well, but they're not really, they're more pre-processing steps, right? So we use PCA in this particular step, in this particular process, and our initial feature set had 147 features. We had a total of 17 different feature selection techniques that we employed. And of course, adding the original data set, that meant we're looking at 18 different data sets, and then we also applied PCA as well. We then also applied 12 machine learning algorithms to these data sets, resulting in over 1,500 experiments that were conducted for this particular research, excluding, of course, experiments that were conducted for the purpose of tuning the model. So firstly, when you think about the filter method, what it is that it's really reliant on statistical techniques that look at your full list of features, and they analyze that full list of features and associate a particular score to that particular feature in relation to the actual target. So these are really statistical measures such as Pearson correlation coefficient and so forth. So when we use filters techniques in our particular research, we found that these methods would result in an almost 30% reduction in the mean absolute scaled error, which was the performance measure we used for this particular research. One interesting observation that we saw is that the Bayesian ridge would actually decline in performance when we use certain feature selection techniques. And the reason for this is that the Bayesian ridge actually fine-tunes its regularization parameters to the actual data. So when you reduce the data through feature selection techniques, you actually do reduce the amount of data that it can actually fine-tune on. And often we did observe a reduction in the performance. But in general, when we applied filter selection techniques, there was an improvement in performance. The ridge, we also saw, sort of performance. So it was interesting to contrast the ridge and the Bayes ridge, just because they are so closely related, except that with ridge, of course, you would use, a grid search, and you would use manual fine tuning in order to set your regularization technique. Whereas with the Bayes ridge, that is actually, fitted to the data itself. Next, I'll just quickly talk about the wrapper method. So wrapper methods are also, they're multivariate feature selection techniques. Unlike filter methods, filter are univariate. This now take into account other features. So although filter methods are good for noise reduction, the problem with them is that they can actually discard a feature which seems unimportant on its own, but that feature is actually important in the context of a group. So the wrapper method does resolve some of those challenges, but they are really computationally inefficient because they use a greedy search algorithm and strategy in order to find the appropriate subset of features to actually consider. So when we applied feature selection techniques here, we only use the recursive feature elimination technique simply because of the computational explosion that we would experience with it. We stuck to only limiting it to 5 features that it was working on. So just to give you a sense, if you are choosing 6 features out of the 147 total features that we had, that's over 12 billion iterations that this process needs to consider, which is very difficult even if you have a supercomputer. And often parallel computing is also not possible with some of these wrapper methods. So when we applied it, we also saw a reduction and an improvement in the maze. So we saw about a 21% reduction in mean absolute scaled error. And we also saw quite a healthy improvement in the deep learning type of models, such as the LSTM and the GRU, which was very interesting for us to observe, because what the wrapper essentially has done is that it's cut away a lot of noise, and it's really restricted this to a set of features that have very limited interdependencies between them, but are somewhat able to actually add some value in predicting the unemployment rate. The last techniques we use were the embedded methods. These are very similar to the wrapper methods. However, they differ in the sense that they are more computationally efficient, and the learning algorithm and the actual feature selection are sort of packaged together. So this would be things like the lasso, where the lasso will create a sparse set of features, but at the same time, it's actually an algorithm that's going to give you a prediction at the end of the day. So they are a lot more efficient, and what they are able to do as well, which is interesting, different to the wrapper, is that they do take into account sort of correlated features, and they try to keep those together. So when we applied this, we did see a reduction of about 15%, except in some cases where we actually saw very interesting results where the eNet and the lasso actually chose the same set of features, which meant that we sort of saw the same, sort of results across the two. So that was really interesting to see. So what we then saw from this is that the filter methods were the most efficient, which told us that from the 147 features, there's a lot of noise in our data, and a lot of those features are not actually helping us to actually predict the unemployment rate. There's only a small handful of features that actually help us to predict the unemployment rate. The difference in performance between embedded as well as REPA also showed us that the correlation contributes to the noise in the data. Hence, we saw the REPA performing better than the embedded method. So remember, the REPA methods often will discard, will only keep one correlated features if two features are strongly correlated, whereas the embedded, such as Lasso, such as ENET, are likely to actually say, let's group the ones that are, really closely related together. And then we also looked at dimension reduction, as I mentioned in the introduction. Although this dimension reduction techniques did not actually give us an improvement when it comes to mean absolute scaled error, what they gave us an improvement in was in terms of time. They really improved the time of actually, running these algorithms and so forth. Where we really saw sort of big jumps was also visible with the deep learning models, which obviously are always very computationally inefficient. So we saw quite a lot of improvement in those particular types of model. But in models that were REPA orientated, we didn't see as much improvement. So that was kind of interesting to see as well. We also saw a significant improvement in space as well, but except when compared to the REPA, because remember the REPA method, we said because of infrastructure limitation, we're only going to stick to 5 features. So the number of parameters was sort of set from the get-go. But otherwise, we did see a little bit of improvement, especially when compared to the filter methods when it comes to space. So the dimension reducing sort of techniques are then useful in our case here from the results if the computational performance and the space is quite important. But our assessment is that that's not the most important thing when you're trying to forecast the unemployment rate. So we don't think that it's actually the most critical thing to focus on. Rather, we should probably not even apply it to the South African context. We should instead focus on filter and REPA methods because we saw an improvement. So through this paper, we're able to demonstrate that indeed, the application of feature selection techniques on high dimensional and non-stationary microeconomic data does result in improved forecasting capability of machine learning, particularly in the context of the South African unemployment rate. For those, of course, that are curious, this was sort of the 7 features, that the machine learning techniques sort of suggested as the key ones in contributing to forecasting the South African unemployment rate. And when we look at them, we sort of come to 2 conclusions: that the South African government needs to improve its financial administration, and then secondly, it needs to be position itself as a globally attractive financial destination, because these features seem to suggest that those 2 are the most impactful things that will sort of impact how this machine learning models actually respond. In the future, our view is that although the focus here was not on forecasting, obviously dimension reducing techniques do help when it comes to visualization. We would recommend researchers to take on that task of visualizing the South African economy using dimension reducing techniques. And also, we didn't look at all possible feature selection techniques. There are ways where we can combine the statistical, capabilities of the filter methods with the computational strategy of the REPA methods to actually have a more efficient feature selection technique that takes advantage of both worlds. So future researchers could look at that as well as future things that they could actually do as well. With that, Chair, I will take questions from anybody that has them.
Thank you for your presentation. Any questions? We have 3 minutes for questions.
Thanks, Rudzani. Thanks for this kind of giving a high-level overview of all these feature selection methods. I have faced this situation myself. When we apply 2 different feature selection techniques, sometimes we see one feature selection technique says that feature X is important and gives high weight, and at the same time we see another feature selection technique gives a higher weight to some other feature, maybe feature Y, and how did you face, how did you handle those situations like where one future selection technique was saying like future X is important and another technique was saying that future Y is important?
Yeah, no, very good question. So we used a little bit of a consensus approach in the sense that we had over 1,500 experiments, and we sort of then looked at the consensus of what are the top features that are being highlighted across this 1,500 experiments. We found the ENET and the LASSO to be the top performing, both as embedded, sort of techniques and as wrapper techniques as well. So we took the features that were highlighted by those as the critical features when it comes to forecasting the South African unemployment rate. What we're also doing as well was also, looking at the data as well, to look at the characteristics of the data and say, like if the data is highly correlated, we would expect embedded methods to actually perform better. If there's a lot of noise, then we'd expect filter to perform better. So we know then these are the sort of features we should expect from the statistical properties of the data. So we use the combination of those two to sort of determine which are the final features that are most meaningful.
Okay, thanks. And another question is, how big was your data set? Besides, like there were 147 features, like how long was this data set?
Yeah, so we had over just under 800 observations, so 794, and then we split that to only keep 24 as for testing, and we use cross validation to sort of test the robustness. So that was the sort of the observation. So this is data from 1960 to 2019.
Well, yeah, okay, I think that makes sense. Thank you.
Okay, thank you. And any other questions from the participants and the audience? Okay, then we'll move to the next presenter, Dimitrios Lukatos, presenting revealing characteristic IoT behaviors by performing simple energy measurements via open hardware software components. The floor is yours. You have 12 minutes to present.
Can you hear me? Hello, everybody.
Yes, hello, we can hear you, yes.
Okay, and now I'll try to make me visible. I think it's okay. Okay,
Yes.
I'm in the laboratory. Thank you all for the opportunity you gave to us to present our work, which has to do with how to estimate in a very fast and cost-effective manner the performance of IoT modules of interest. I'm gonna share my screen and start the presentation. Well, here. Okay, this is the window I want to use. Okay, just a moment. Yes, this is sure. And let's start. I guess you see everything is fine.
Yes, it is visible.
Okay,
yes.
okay, nice. So I'm gonna present you the paper, our recent work entitled Revealing Characteristic IoT Behaviors by Performing Simple Energy Measurements via Open Hardware Software Components. I'm the first of the researchers involved in this work, along with Dr. Dimitriou, Manolopoulos, Kontovasilis, and Arvanitis. Two teams collaborated, one from the Department of National Natural Resources Management and Agricultural Engineering of the Agricultural University of Athens, and the other from the National Center for Scientific Research, Demokritos. also from Athens, Greece. Internet of Things is something very important and very rapidly evolving over the last years. Apparently, the progress in mobile devices, smartphones, electronics is giving a boost to all this IoT stuff. A huge number of devices being interconnected have to cooperate it and be active around us. For this reason, the energy optimization and apparently the minimization of it is very important. And in order to tackle with this issue, we have to perform very, very effective measurements over these devices. Actually, the activity profile of these devices can be has to be studied and can be adjusted in order to minimize this energy consumption. Most of them are capable for sleep mode, and most of them again have a bursting behavior between activity and inactivity or idling or sleeping periods. A lot of card-sized computers like Raspberry or Arduino made quite easy the monitoring of these processes. Actually, we have two basic methods. The first method is to record and study aggregate quantities and extract metrics from it. The other one is to study instantaneous quantities and perform short time and reveal the short time dynamics of the modules of interest, like power consumption instantaneously, or while a packet is transmitted or a video frame is transmitted. The method A needs more time, while the method B is, although sometimes less accurate, can be very, very effective uncovering, revealing irregularities and quite unknown behaviors of the modules of interest. We are going to use Arduino-like boards, low-cost components like capacitors, resistors, radio transceivers, and digitizers, simple and fast deployment tools like Arduino IDE and the Meetup Inventor environment, and an extra ADC module for digitizing, equipped with the ability to perform fast differential measurements. What the basic method is to measure the voltage drops over a resistor of known constant and quite small value, and a resistor that is tolerant to 2 to 5 watts. This value is a trade-off between small values that do not disturb the operation of the modules under testing, and larger values that allow for readable quantities by the digitizer system. A capacitor can smooth slightly the behavior of the system in order not to lose some sudden peaks that are happening. This is an overview of the modules being used. We have a basic, at the top left part, we have the resistor, the capacitor. At the left part, we see the module that is the digitizer. The main measuring board that does that performs the computations is this one, initially an Arduino Uno and later an Wemos board. A USB link provides access to a computer for visualization, and also a Wi-Fi link for better visualization using a smartphone. The module of interest under testing in this case is an ESP32 based IoT camera, which was set up as a video server. Wemos is something better of using than Arduino Uno, as is faster, has more memory, and gives better connectivity options, especially paired with a Wi-Fi, with a smartphone via Wi-Fi links. Results. First set of results are involving an ESP32 camera, and we captured the power consumption, the current consumption, to be more specific, during typical camera activity, from resetting to delivering real-time video traffic. The serial plotter tool of Arduino IDE can easily visualize the results. The camera has web interface. It's exactly the arrangement shown here. And here we can see what happens when I order the camera to start the video streaming. At this setting, the camera transmits a frame as fast as it can. We see the lift, the shift in the current consumption here. And the second case has to do with the camera. The frame rate is lower. We modified the software to deliver 2 frames per second. And we take, using the serial plotter tool of Arduino IDE environment, we took screenshots of the 5,000 last points of activity. Here, the camera here at the top left figure starts, but not the video system, only the module. The module, the ESP32 module. There is some canonical peaks at an interval of 200 milliseconds each, corresponding to the beacon to the beacon signaling frames of the Wi-Fi link, and after this period, the camera starts. There is a lift in the amperage consumption of the camera corresponding to the initiation of the video delivery process. And here we can see the amperage consumption peaks caused by the delivery, the generation and the delivery of each separate video frame. So short time dynamics can be easily extracted by the proposed mechanism in a very, very cost-effective and simple manner. LoRa protocol is also a very attractive option because it consumes very, very few energy in order to perform transmissions and has long range capabilities. We can is very attractive LoRa because its characteristic, the bandwidth, the spreading factor, and the transmit power can be adjusted in order to provide to cover a very wide area of different behaviors. So it's very important to fine-tune such a module. And in our example, we see the impact of spreading factor or transmit power modification to the amperage consumption of the module during the transmissions period. At the left, at the top, the two figures at the top, the spreading factor is set to 10. So shorter spreading factor means shorter time intervals in order shorter time periods for a packet, for a single packet to be transmitted, while for the same type of packet, larger values of greater values of spreading factor is parsed in longer time periods for each packet to be transmitted. Also, when we modify the transmit power, we see a lift of the power. These two cases are with at lower transmit power level of 114 milliamperes, while in both cases shown in the bottom part of this figure, the transmit power goes to up to 180 milliamperes. These peaks also correspond to the beaconing stuff of the hosting module and not to the LoRa module, because the hosting module under testing was a WIMOS device equipped with a Wi-Fi interface for fast adjusting the LoRa parameters, and of course had a LoRa hat, a LoRa shield on it, a LoRa Dragino device for transmitting LoRa frames. We highlighted the feasibility of capturing short time dynamics using cost-effective and simple methods, and using components like WIMOS ESP8266 or ADC converters like the ATS 1015 modules, Arduino IDE with serial plotter and serial monitor functionality, and Meet App Inventor for fast deployment of smartphone applications. ESP32 camera and a LoRa capable module where the IoT device is under testing. And as next plans, we try to combine this data being collected with AI functionality in order to characterize the traffic in an automated way. Thank you for your time. And also, our method is fast. It is not the more accurate one, but for a comparatively low energy devices are very effective. For greater for devices of greater power, Hall effect sensors, magnetic one, would perform quite well, but not for low amperage devices. Thank you.
Thank you, Doctor, for your presentation. I have 3 minutes for questions. Any questions from the audience? Okay, so there is no other questions. Thank you, Doctor, for your presentation.
Thank you.
Okay, I sincerely thank our authors for their excellent presentation in this session, and all our participants for being a part of this international congress. I hope this session was informative and knowledgeable as well. All the presenters would be getting their digital certificates through mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 4 to 6 months. Kindly cooperate with the team of ICICT as and when intimated. I also want to thank our session chair, Professor Casey Santos, which unfortunately he couldn't join us today, but his colleague joined, Dr. Haroon Lone, for chairing this session, a token of appreciation to the chair on behalf of Team ICICT and Global Knowledge Research Foundation. Thank you all for your valuable presence. And I kindly request everyone to turn on their cameras just for a quick snapshot for the virtual conference, please. Okay, thank you.
Thank you, Professor Haroon.
Oh,
Thank you,
welcome.
Professor.
During this session, and we appreciate the participation of yourself as a sparing your valuable time. I understand that Dr. Casey Santosh was not able to present, but definitely we appreciate your gesture and your kind participation to this session. Thank you.
Sure. Thank you.